Okay, for this, we're asked to find the inverse of each one of these relations. So the first one we're going to tackle is this question number 1. So right now, the relation 1 has the y equal to minus 3x plus 2. Remember that the inverse relation interchanges the roles of x and y. So I've got negative 3y plus 2 is going to be the rule for the inverse. Now, a little bit of algebra reminds us, I'll just subtract 2 from both sides and divide both sides by negative 3. That's going to be solved for y. Just to clean it up a little bit, I'm going to just make it so that it's a negative x plus 2. Negative x plus 2 all divided by positive 3, just a little prettier that way. And so that's going to be the rule for how I generate y, which means that R1 inverse is given by the set of ordered pairs xy, where y is equal to negative x plus 2 over 3. Okay, so just a little bit of algebra is needed there. In a similar game, on the second question, for finding the inverse of y2, notice that my relation currently is y is equal to x squared plus 2. So I'll interchange x's and y's. I'll do a little bit of algebra. I've got x minus 2 is equal to y squared. I would introduce a square root in some meaningful way. Just note, I'm going to write x minus 2 is equal to the square root of y squared. Just to the side, we will refresh. The square root of y squared is equal to the absolute value of y. Square root is always a positive output. It gives us the absolute value. So this is the absolute value of y. Square roots of x minus 2. But we know something about the absolute value of y being equal to something. What that tells us is that either y is equal to the square root of x minus 2, or because that has an absolute value, which is the correct thing, or it's the case that the square root y is equal to the negative square root of x minus 2. Okay. So my inverse relation, R2 inverse, is equal to the set of ordered pairs xy, such that that rule here, y is equal to x, the square root of x minus 2, or y is equal to the square root of, which is negative, x minus 2. Okay, by just similar kinds of algebra, for the third one, you'll notice that the R3's inverse is going to be the set of ordered pairs xy, such that we find that y is strictly less than x plus 4 divided by 3. Okay, as the opposite of that relation there. Scrolling down, R4, because R4 is the relation x is the parent of y, R4 inverse is going to be given by x comma y, such that x is the child of y. We've interchanged the roles of x's and y's, which means we have to reinterpret the meaning of the relation. And finally, R5, its inverse, is going to be the set of ordered pairs, x and y, such that interchanging x and y, x is a sibling of y, because, again, you are your sister's sibling, and your sister has a sibling, which is you. So, in fact, that is its own inverse.